These notes are about how we would go about solving exponential equations. What is an exponential equation? We've seen some before. That's an equation where the variable is in the exponent, and we're going to talk about how we can go about solving those. Before we begin, though, there's going to be two facts that we're going to need for this. The first one is what we've been using this whole unit, and that's switching forms. If we know that b to the a is equal to x, that tells us that log base b of x is equal to a. Same sentence, just written in a different form. And we have to make sure that we're comfortable going from one form to another, otherwise these solving exercises might be kind of challenging. The other fact that we're going to need is our change of base rule, which we've talked about, our change of base formula. And that's if we have log base b of a, I can pick any base that I want and have that be log base, our new base, of a over log base, that same base, of b. So more often than not, you're going to pick c to be something like 10. I love changing things using base 10 because I know that's what our calculator can do. So our two facts, switching forms and using our change of base formula. Let's see how we use them. Our first example, we're going to be solving for x. 2 to the x plus 5 equals 17. Notice first that this is definitely an exponential equation because our variable is in the exponent. How do we get that variable out of the exponent? We're going to need to use logs. So if we switch forms, if you refer back to how we would do that, I know that's going to look like log base 2 of 17 is equal to x plus 5. All we did was we just rewrote our original sentence in log form. Now you can see I got the variable out of the exponent. It's no longer trapped up in the superscript. We now have x plus 5 is equal to something. What number is log base 2 of 17? We're going to use our calculator for this, and for all of these examples we're going to round a little bit. But the problem is I don't have a log base 2 button on the calculator. When I type log on the calculator, it's assuming it's base 10. We talked about how some of the newer calculators you are able to put in a base. I'm going to assume that we don't all have those newest calculators, and it's a good skill to know anyway. Let's try to use log base 10. So we'll use that second fact that we talked about. Log base 2 of 17 is equal to log base 10 of 17 over log base 10 of 2. That is something I can type in my calculator. So I have my calculator right here. The log key I can see is actually all the way on the left-hand side. It's next to the 7 button on mine. And I type log 17. Remember to close the parentheses. The calculator kind of opens them. I have to remember to close them. Divided by log of 2. And I get 4.0874, whatever. I'm going to round on my page when I'm writing this down. I'm going to round a little bit. That's 4.0875. 746, so 75. Remember that that was equal to x plus 5. So we have about 4.0875 is equal to x plus 5. And now our last step to get x by itself is to just subtract 5 from each side. So luckily I didn't delete that crazy decimal in my calculator. I'm just going to do answer minus 5. So that way I'm not rounding until the very end of my problem. X is about negative 0.9125. I'm going to stick with 4 places after the decimal because why not? So let's just recap what we did. We put it in log form. In order to figure out what log base 2 of 17 was, I used change of base on the calculator, and then I just continued solving for x, because it actually was just a linear equation after that. Let's look at some more examples. Here we have 3 times e to the x plus 2 is equal to 100. You might be tempted to go to log form right away, but we can't because we don't have something that's purely written in exponential form. A to the b equals c, or the way I wrote it before, b to the a equals x. We have to deal with that 3 coefficient first. The way we can get rid of it is divide both sides by 3. So now I have e to the x plus 2 equals 100 thirds. Again, to avoid rounding too early, I'm going to leave that number as 100/3. I'm not going to bother rounding that to 33.3 or something like that. Now it looks like exponential form. B to the a equals x. So we can switch to log form. Log base e of 100/3 equals x plus 2. You'll never ever see that written, really, though. Log base e, that's the same as saying natural log of 100/3 equals x plus 2. So now, on my calculator, if you take a look, right below the log key is an ln key. We don't have to use change of base formula here because your calculator can do log base e. So I love it when things are log base 10 or natural log base e, because I know that the calculator can just give me an approximation fairly quickly. So I know I can do that, but I know the last thing I'm going to want to do to get x by itself is subtract 2. So x is equal to natural log of 100/3, and then whatever that is, minus 2. That's an exact answer the way I have it written, because I haven't done any rounding. Let's get a decimal approximation. Natural log of 100/3 minus 2, when I hit enter, I get that x is approximately 1.50666. It was 50655. I'm going to call that 1.50666. So it's important to be able to get that decimal approximation. You want to make sure that you know how to type that into your calculator and how to approximate. Let's do one more example. Here we have a question, do we always need to use logs if we have an exponential equation? And the answer is no. You've actually solved some exponential equations already, just based on kind of thinking about perfect powers. We have here 9 to the x equals 27. And if you think about what kind of number x would be, 9 to the 1 is 9, 9 to the 2 is 81, so it's not going to be a whole number. But we can solve this without even using logs. 9 and 27 are both really nice numbers because they are both powers of 3. 9 is really 3 squared. So 9 to the x, I'm going to write that as 3 squared to the x. 27 is 3 cubed. So using our exponent rules, I know that 3 squared to the x is the same as 3 to the 2x is equal to 3 cubed. Look at this statement. You have 3 to the power of something equals 3 to the power of something else. So the two things that are circled must be the same. If the bases match, then the exponents have to match. 2x has to be equal to 3. We turned our exponential equation into something a lot nicer, just a linear equation, just based on what I know about powers of 3. Now if we solve for x, x equals 3/2, or 1.5. Oh, that kind of makes sense why we couldn't have just kind of guessed that in the beginning. I don't think you would have guessed 9 to the 3/2 equals 27, but we were able to solve for it. Those are all very basic examples. Of course, solving exponential equations could get a little bit trickier, but if you understand those basic steps, then you're probably prepared to attack any level of exponential equation. Good luck!